Okay, this is paper 2 of the paper. Unfortunately, I realized that I have lost my projector. So when I'm going through question 1, I'm going to estimate the angle. But when you are doing it, please use a projector. Okay, I'm going through the steps, so I won't be able to calculate, or I won't be able to measure the exact value. So please refer to the answer key given to you. Okay, so let's start with this question on free body diagram. So you are told the load of, you are told the weight of this load, and you are asked to deduce the tensional force inside this cable. Now the thing is that because the load is stationary, meaning that the whole system is in equilibrium. So in that case, you should be expecting a closed triangle. Okay, from the free body from the vector diagram that you are going to draw. So look at the forces first. Now the first force, I think, is the most obvious one, is the weight here. You know that it is vertical, you know the magnitude, so you already know both the direction and the length, so that's okay. Now if you look at the tensional force, you do not know how much the value is, but you know that it is going to act 20 degrees from the horizontal. So you know the direction, but you do not know the magnitude. Okay, number 2, you need to look at the scale. So for 1200, I think it is quite reasonable to have a scale that is 1 cm to 100 Newton. So this 1200 Newton will become 12 cm, and I think that is okay. So let's start drawing the thing. So I already drawn the first one. So this is the weight factor, is 1200, and it is vertical, so you already know. So the next thing is that you are going to draw one of the tensional force, and I'm going to draw the tension in BC first. So if you look at the force in BC, you know that it's going to act 20 degrees from the horizontal. So because I lost my projector, I'm going to use the tail head method as well. So this is the beginning of my vector. So this is the tail, so this is the head. So I'm going to start here, because tail to head, the next tail should appear here. Okay, so I'm going to use my projector, and I'm going to measure let's say around here, 20 degrees from the horizontal. So you have to use your projector. Okay, you have to use a projector, but because you do not know what is the length of the, you do not know what is the length of the tension, so you cannot just say that, okay, I'm going to stop here. You can't, because you do not know what is the tensional force. So what I suggest you to do is that, since you do not know, just extend it as a guideline. Okay, I think this 20 degrees is too small, so I'm going to re-estimate it. So 20 degrees should be about here. Now you do not know the length, so it's okay, just draw it. So this is 20 degrees. You know that this is your tension in BC. You do not know the length, so you do not know when to stop. Now, so because of that, you cannot draw your third force from this line, because you do not know where does it end. But you know that because it is a closed triangle, so tension BC definitely act this way, because this is the tension, right? So it has to pull on this direction. So you know this way. So you know that the next force must be coming like from here, right? And if you look at this thing, you know that, oh, okay, it's going to end 20 degrees from the horizontal as well. So from here, you know that, okay, it's going to end 20 degrees from here. So use your projector again and start measuring. Okay, let's measure 20 degrees from here. And again, you do not know the magnitude of the force. So you do not know what's the length of the line. You only know the direction. So what you're going to do is that, never mind, just draw first. So then you realize that, oh, okay, this is the intersection point, and because you are expecting a closed triangle, so meaning that your tension BC must end here, and your tension in AC must start here. So you will get your closed triangle in this way. You got all the direction correct. So what you're left to do is that just measure the distance here, and you can find out what is the tension in your cable BC and in your cable AB. Okay? For your part B, why is it that the horizontal cable is very likely to break? Now, I like this question because even for me, I make some errors. Not really error, but I didn't. I feel that I haven't highlight. I feel that I didn't identify one of the key point in my original answer. So what I did is that I just simply explained that when the cable is becoming horizontal, the tensional force in the cable is going to increase. Now, some of the students may not be able to see this relationship. So what happened is that if you look at your free body diagram, okay, now if the cable is going to be more horizontal, so if you look here, if the cable is becoming horizontal, that means this angle is going to decrease, right? So if you look here, if this 20 degree is going to decrease, what happened to your free body diagram is that this two line is going to be elongated. So I'm going to sketch it. So what happens is that if your cable is at 20 degree, your triangle looks something like that, 20 degree, right? But if now your angles is becoming more horizontal, your triangle is going to elongate, okay, as this angle becomes smaller and smaller. This angle becomes smaller and smaller. So when the triangle elongates, what is happening to your tension is that the tensional force is going to be increasing. So that's why if you understand this relationship, when the cable is becoming more and more horizontal, the tensional force is going to increase tremendously. Okay, and this will draw nearer to the breaking limit of the cable. Now what I have not included in my answer is that I didn't explain why does the tensional force in the cable increase when the cable become horizontal. I failed to indicate the explanation. So remember, when you are seeing this explanation, it's not enough to just state a relationship. So what I have stated, cable become horizontal, tensional force increase, is a relationship. It is not an explanation. So after you state this relationship, it's better to include an explanation. Okay, and this tensional force is increasing is because it is necessary to balance the weight of the load. Okay, it increases because it is a requirement. It has to increase to balance with the weight of the load. Okay, then after that you relate it back to the question, and this draw nearer to the breaking limit of the cable. Okay, for your C part 1 is quite easy. You are given the mass and then it is on Earth, so just multiply by 10. Now the work done here, that is the tricky part. So what happened is that this smooth cable ABC, they are still referring to this thing here. Okay, it makes an angle of 20 degree. So they ask you to calculate the work done. So when you are calculating the work done, okay, WD equals to F times D. The distance that you are going to plug in here must be parallel to the force. And in this diagram, the force acting on the load is this weight, and the weight is vertical. So when you are considering the weight here, the distance here must be the vertical distance, meaning that you have to find the distance here, the vertical distance. And this vertical distance, if you use your trigonometry, is just the length of BC multiplied by sine of 20 degree. So this is how I get it. So half of the cable is 30 meter and is making an angle of 20 degrees. So when you are calculating the height, you just take 30 times sine 20, you'll be able to get the work done. Okay? This is the answer. Okay, question 2 is like a scaled down version of a database question. So let us do it part by part. It's quite straightforward. So what happened here is to find the weight, but the G here you have to use the gravitational field of the moon. So you get the weight on the moon. Net force, please take note, when you are calculating the spacecraft, there will be two forces acting on the spacecraft. Okay, number 1 will be your weight, and number 2 will be the upward thrust. So that's why your net force, you have to take the upward minus the downward force, you will get the net force here. So once you get the net force, use your Newton's second law, F net equals to ma, you will be able to find the acceleration. Okay? How fast it will be after 30 seconds, use your acceleration formula, plug in the value, initial velocity, because it starts at rest, it will be at 0. So you will get the velocity. How far will it be in the moon's surface? Now, what you can do is that, since you already know the final velocity, just sketch out a very simple VT graph. And because in this case you are in the moon, so meaning that there's no air resistance, means that your acceleration is going to be constant. So you start off at 0, you are going to find out the distance traveled at 30 seconds. So 30 seconds. So 30 seconds is what you find in part B, 30 seconds or so. So you already know that at 30 seconds, your speed is going to be 30. So how far will it be from the moon? It will be just the area underneath the speed time graph or the velocity time graph. So half times your 30 times 30, and you'll get the answer. So now you have to comment what will be the actual traveling distance. Now if you look at this calculation, the acceleration, this gradient, the acceleration that you got comes from this part of the graph, this part of the question, and you are actually assuming the F net here to be constant. Okay, and the F net is actually made up of two forces, the thrust and the weight. Now the thrust will be constant because that is how fast you burn your fuel. But the weight here is not in actual fact, because as you burn your fuel, okay, the fuel will have some mass. So actually the weight of the spacecraft is actually decreasing. If the weight of the spacecraft is decreasing, means that your F net will be increasing. If your F net is increasing, means that your acceleration is increasing. If your acceleration is increasing, of course, that means the actual distance traveled is going to be larger. So that's why explain it in logical steps. So in this case, I start off with the weight of the craft is actually decreasing as the fuel is being consumed. So as such, the acceleration is increasing, and hence the distance traveled will be further. Now, another reason is that gravity is actually dependent on how high or how far away you are from the planet. So that's why the further away you are from planet Earth, the less gravitational force you will feel. So actually the G here is not constant. So meaning that the weight of the spacecraft itself is actually decreasing as the spacecraft exceeds the planet. But of course, the change in height must be drastic. So actually 450 meter, well, it actually is like your skyscraper height. So I would say that if you state that the gravity is getting weaker, yes, it is a valid reason, but I don't think it is that significant compared to the consumption of the fuel. Okay, but if you state gravity is weakening, I will give you the mark as well. Okay, the last part of the question asks you to comment on the spacecraft if it is on Earth. Now, because it is on Earth and because you know the mass of the spacecraft, and it is also because the nature of the question is like a database question, you have to make use of the values given in the question to make your conclusion for part G. So because you know the thrust is 5200 and you already know the mass and you know the gravity of the Earth, you can actually make use of numbers to strengthen your argument or strengthen your prediction here. So first use calculation. So on Earth, the weight of the craft is actually 200,000 Newton, and that is greater than the thrust force because the thrust force is only 52,000. So 52,000 is definitely less than the weight of the spacecraft. So hence your spacecraft actually cannot take off. Okay, it will be too heavy for the spacecraft engine. Okay? Okay, question 3 is very straightforward. You shouldn't get this wrong if you have read the question carefully. The mass of the block is given by 0.46 and you can deduce the volume by the volume of water that is overflowing here. So just plug in the value. What you need to be careful is that the volume here is in cm cube. So if you want to, if you do not want to change the cm cube into meter cube, it's fine. Just that your mass, please change it to gram. And remember to state the correct unit here. Okay, and you should be fine. Those of you who want to use kg per meter cube, please go ahead. I will also accept it. But be very careful when you change cm cube to meter cube. Okay, if you do not know how to do the conversion, come to the office, look for me, I will help you. Okay, explain why it is impossible to use this method. That is because your wooden cork will float on the water, and if it is not totally submerged, you won't be able to tell the volume accurately. So in this case, when you are explaining this question, okay, for those of you who just write that, oh, the wooden cork is going to float on water, I will give you 0 mark because you have not relayed that observation to why is it that this would cause this method to be unable to determine the density. So relate your observation, which is the cork is going to float, to the volume. Okay, because once you make this relationship, then it is very clear that without the accurate volume, you won't be able to tell the accurate density. Okay, so even for a 1 mark question, please take note of the way you explain, okay, yourself. Question 4 is actually a very straightforward moment question. So the weight, you have to draw it pointing down and remember to label it as the capital W. Once you do that, all you need now is your principle of moment. So you have 2 forces, so the pivot is actually here. So this weight is going to give you an anti-clockwise moment, and this force from your feet is going to give you a clockwise moment. So in order for this to be in equilibrium, okay, you need to take the clockwise moment and equate it to the counterclockwise moment. Now remember, the distance has to be the perpendicular distance from the force to the pivot. So you can see they already give you the perpendicular distance here, they give you the perpendicular distance here. Now remember, the 90 degree is always from the distance factor to the force factor. Okay? So this question is actually very lenient. They didn't give you any additional information to confuse you. If it were me, I would give you this distance, and let you make the choice. Okay, so for here, just put in the correct value. So for the weight, the 300, multiply by the distance here. Then after that, do your algebra. You'll be able to get the lifting force. Okay, questions 5 is your pressure question. I make a mistake here as well, so be very careful when you're calculating these things. Down here, they're actually asking you to find out the force here. So the force on top is just your atmospheric pressure, so use your P equals to F over A. Plug in the value, you'll be able to find the force. For part B, you are supposed to find the pressure acting on the diver submerged in the water. And actually, they want you to get the total pressure, that's why they bold it here. And even for me, I forget about this. So what happened is that first you must find the pressure from the water. So since it's liquid pressure, it's only dependent on the height, so use your ρgh. Now this is not the total pressure because the diver is under the layer of atmosphere. Okay, the diver is actually feeling the atmospheric pressure plus the water pressure. So down here, your total pressure is actually equals to atmospheric pressure plus the pressure from the water. So it's actually your 100,000 plus this 8,000 from the water. So your total pressure is actually 108,000. Okay. Question 6. It seems that a lot of schools like to give this kind of question. So be very get used to explaining this, and you shouldn't face much problem because it's quite straightforward actually. So what happens is that state that when the volume decreases, the number of molecules per unit volume actually increases. Okay, that's one key point. and this would lead to an increase in the frequency of collision. Now notice, it's just the frequency of collision. Okay, the force of the collision is still the same because the temperature has not increased. Okay, it's just the frequency of the collision. So as a result, the average force per unit surface area, notice that I'm not saying that the average force increase, it's the average force per unit surface area, because with the decrease in volume, the surface area is going to decrease. So this ratio of force per unit surface area is going to increase. So another point to take note is that I include this, although it is not necessary to have this statement. Now the molecule's average speed is going to be the same because temperature remains constant. That's our assumption. Okay, I'm just including this statement for the sake of the purpose of this video. Okay, so then after that, finally end it off. So hence pressure increase. Okay. Okay, question 7 is your thermocouple. So remember your thermocouple, the relationship is difference in temperature is directly proportional to the current. So with the table, you can find out the constant K here, what's the value, plug it into your new situation whereby the current increase is 18 the voltage increase is 18 millivolt. Oh, okay, sorry, I think I made a mistake here. It's not the voltage, it's not the current, it's the voltage. Actually, they are the same lah, as in it will be directly proportional. Okay. Okay, the question 8 is quite straightforward. The system here is quite easy. So what happens is that this clock will measure the time when the sun is up. So what happens is that when the sun is up, the mercury is going to get heated up, then it's going to expand, then it's going to connect. This is going to fill up the gap here. So because mercury is conductor, so you close the circuit, and therefore the clock will actually be running only when the mercury has expanded to this level. Okay, so let's attempt this question. How does the energy from the sun reach the mercury? Explain your answer. So even though it is a 1-mark question, I find that because they ask you to explain, and for the energy to reach the mercury, there are actually 3 possible ways, right? 3 ways that energy can travel: conduction, convection, and radiation. And you need to explain. You need to indicate which of them is the main mode of heat transfer. So take note that there is a layer of vacuum here. So because of this layer of vacuum, the only possible heat transfer method is actually your radiation. So to have a complete answer, I decided to give a positive explanation and a negative explanation. So energy reaches the mercury through radiation only. So I state my conclusion first. Then I explained that because of the vacuum inside the glass case, it actually prevented conduction and convection from transferring the heat to the mercury. And only radiation can transfer energy over a layer of vacuum. Okay, so I include a negative explanation why conduction and convection is out, and I included a positive explanation. So why the clock starts when the sun shines? So I explained it at the beginning of the question. So when the sun shines, the black surface actually absorbs the sun's radiation, and because of that, the mercury inside the blackened glass probe is going to absorb the energy and expand. And you have to indicate that the mercury level would rise and close the gap between the wire. And very importantly, you have to also state that the mercury is an electrical conductor. Okay, if you didn't state that mercury is an electrical conductor, you won't be able to explain why the clock actually starts. Okay, then finally you state that the circuit is closed and the clock starts ticking. Okay. So why the blackened bulb? Why the mercury level falls rapidly? Okay. You must be able to identify that the black surface is a good radiation emitter. And because it is a good radiation emitter, it actually enables a very rapid energy loss to the surrounding, okay, when the sun is down. Okay. Okay, question 9, they are playing tricks with you. Actually, it is very simple. So, I'm going to demonstrate to you how am I going to attempt this. So, you have to draw a scale diagram. So let's draw a scale diagram. Okay, so let's set this up first with a straight line. So this is my reference line. I am going to put my object here. My object height is 1.6. So I'm going to draw 1.6. Okay. It's my O. Distance from object O to lens 1 is 4 cm. So let's draw 4 cm here. Remember, your lens symbol is a double arrow. So this is your lens 1. Distance between lens 1 and 2 is 6 cm. So 6 cm. Focal length of lens 1, 1.5. So this is f1. And focal length of lens 2 is 2 cm. So once you have this, everything is as per normal. So let us begin with lens 1 first, because the light is going to be emitted from the object. So first ray always pass through the optical center, so you have this. Okay, then after that you will be followed by a horizontal ray. Oh, okay, it's quite thin. Okay, then this thing is going to pass through the focal point. So let's stop here first. Rub this away. These are the extra. So I know that my first image is going to be here. This is I1. So then remember to indicate the direction of the light ray. So once you have that, the light ray of course is going to continue, going to shine anywhere. Okay, remember light is emitted in all directions. Okay, so meaning that there will be light. Then meaning that this thing will go here, then after that it's going to cut right here also, So you will have like a lot of light ray going in all direction. Light ray in all direction. So because the light ray is going in all direction, we are going to pick the two light ray that is critical to us. So how to continue from here is that just treat the I1 as an object. Okay, so I'm going to erase the unnecessary rays first. So just treat it as another object. Okay, so this guy is going to cut through the optical center also. There will be a light ray that's cutting through the optical center also, so cut it. Then there will be some light ray coming this way, then cut the focal length and you have this. So your I2 will be somewhere here. Now some student may ask me, teacher, how come suddenly this ray come to here then suddenly change direction? Actually it didn't. This light ray actually will continue going straight and then hit the lens and then focus on here again. But because this light ray, if I'm going to analyze how the ray is going to pass through lens 2, this light ray is not that important to me. So that's why I'm not going to continue with this light ray. I pick another two light ray. Okay, so some of you may ask me, teacher, then how come, where does this two light ray come from? It actually comes from the object. So if now I trace back this light ray, right? This light will always go in straight line if there's no external influence. So this light ray is going to come from here. Then you may ask, hey, then this one from where? Oh, of course, this one is going to be coming from your tip. Because it is horizontal, so it must cut here. So actually this ray actually comes from the object. Just that when I am trying to locate my first image, this light ray is not that important. Or I would say that I can use this light and this light ray to form this image. That's why I say light is being emitted in all directions. Similarly, if you ask me, teacher, so where does this light ray come from? This light ray. So just continue drawing it. So this light ray actually come from, again, the same thing. Okay, this light ray actually come from here, or from the source. Okay, just that when I'm considering this image, I'm not using these two light ray to help me locate the position of this image. I'm using other light ray. In fact, there are light ray going to this direction, this direction, this direction, this direction. They are all going in different direction. All the other direction they are going. There will be light ray going to all the direction. Okay, just that when I want to locate this image, I'm using these two light ray, and when I'm going to locate this image, I'm going to use these two light ray because of convenience. Okay, so I hope that answers your question. So now if you want to compare object O and I2, it's quite similar. So first, the size is diminished, it is upright. Okay, is it real or virtual? It's real. So that's all. Very straightforward. Okay, I will pause here.